Hey, welcome back to the Builded Basement. So this is going to be our last video about the tap, specifically on the CNC tap, and measuring the differences between that and the original tap that was on this Ultimate Voron 2.4, my build. This time we've got the Kinematics bed back on this thing. We're testing out the idea that the Kinematics bed actually doesn't work with tap. I'll give you a quick hint right now, it does. Is it as accurate? Let's find out. Let's jump right into it. All right, for fun things today, we got the bed here. It's all set up. We put it back in. It's perfectly aligned. Everything's where it wants to be. If you are with the videos before, and actually let me switch into a camera where you guys can see me at the same time. If you guys are with the videos before, you remember that the front right corner is the most easiest corner to push down. Left corner, much harder. And I can explain that real quick. Let me, first of all, let's raise this up. Let's take the Z and bring it up 25 here. Give me a second. So I'm not gonna take the bed off completely because I'll have to unwire it, but what I can tell you, and it's kind of hard to see right here, but you have roller pins on here that allows this bed to go left and right just fine. You have this one here that's hauled out, so basically you have a rotational pin right here so the bed can rotate. And then finally in the front, you have a location here that basically allows the bed to, if I can get on there right, to move in any direction. So with all three of those, the bed is relatively rigid, except for the fact during expansion and contraction that bed can move, so you don't get as much of a warped bed. It's kind of the whole point behind this. So it's on there, it's good, it's permanently, it's back installed, everything is tied down pretty good. Let me jump over to this view real quick, if I can find it, right here. That's where I want to be. Also have my nozzle cam up and running. You should be able to see that right there. I will tell you there's a little bit of a delay on that nozzle cam, and I do have the LED set to blue right now, but that's fine. That was my finger on there. So, I mean, that thing is really nice, by the way. That's a 3DO nozzle cam. Bought that from KB3D. He has them available, Chris over at KB3D. If you decide you want to do something like that, go over there and just harass him a little bit, tell him I sent you. So yeah, let's jump right into it. We have our spreadsheet ready to go. Let's get our information here. And let me bring my spreadsheet over real quick, just so everybody knows. Assuming that you did watch the previous video about tap and where we're at, but maybe you didn't. I hope you did, but maybe you didn't. Let's bring that up real quick. So we have a spreadsheet right here where we did our standard deviation, our max, our mins, 5 tests on this, each test consisting of 30 samples, so 150 samples in total, and then basically an average of all those samples bring together. The first one with the standard tap, the built tap that we had, I still got that guy right here, and I gotta say, it was built pretty well. I think I did a good job with it, and it works really well, and there's absolutely nothing wrong with it. It performs as well as I think it should, as well as it's going to out of plastic and with the materials I had. So anyways, you get that. That's with a cold bed, cold nozzle, and then we have the 70-degree bed, 150-degree nozzle test on that. So we wound up with a standard deviation with the cold bed, cold nozzle, with the original tap on there of 0.0008 right here. And then we did the same test again, this time with a heated bed and a heated nozzle, 70 on the bed, 150 on the nozzle. And we wound up with a 0.005, which wasn't too great. Kind of disappointed in that one. Kind of surprised, actually, it changed that much. Not looking into it, this is not 100% scientific, but it's just my takeaway. It's my testing that I did real quick. It's not a horrible number though. I mean, these are really precise. We're splitting hairs of a hair of a hair of a hair. These are really small amounts. So the next tests we did here were on the CNC tap, the actual tap that we just installed, the Chaotic Lab CNC tap, which is available from Fabrico as well as directly from Chaotic Labs. So if you you didn't see the video where I installed it, I did some other stuff with it, go ahead and check that out. I did purchase my unit, and I do think it works pretty well, and I think it's actually a good part to actually buy that CNC. I'm not a big fan of all the CNC parts that we're seeing coming out. I think a lot of them are kind of gimmicky. I would say print your own parts, or if you can't print parts, do the print it forward. But with this particular part, because of the thinness of some of those mounting portions that are attaching directly to the rail, I don't think plastic is necessarily the best material for that. So the CNC tap, I think, makes a lot of sense in that instance. So we did it cold with cold nozzle, standard deviation at the end, averaged at 0.005. So 0.0003 zeros. Three, not two, three zeros on there, so a little bit better than we were at the plastic tap. Not hugely better, we're 0.0003 better. Again, splitting hairs here. And then finally we have the 70-degree bed 150 nozzle, where we are at 0.0015, which was substantially better than the plastic unit, which may have something to do with the temperature of everything that was running. Again, really thin plastic, really warm temperatures around that. Could have made some differences there, but I can't guarantee that. Of course, my Voron, as it stands currently, does not have all of the it's not a completely heated chamber because I don't have the sidewalls on it yet. So, but today, let's jump into today. Sorry to be long-winded here, but today what we're doing is we've got the kinematics bed back on here. Those tests are all done directly on the bed, hard mounted, just like they would be normally. Still using the ultra flat mag bed from Mandela Rose Works, but this time we got back on the kinematics mount, and we're going to do the same testing. And with that, let's go ahead and start that. Okay, so let's get over to our console. We're at cold right now, cold bed, cold nozzle, and I'm going to switch over to a more fun camera. I think this would be a little bit more fun. Of course, I'm probably gonna be stuck behind it, but it's our high-end nozzle cam, right? That's a 4K camera right there. It is smushed down on the screen right there. But I'll leave this up while I'm doing it, and then I'd be copying and pasting stuff in. And once I get through all 5 of them, then I'll show you what we got for numbers. So it'll kind of be a surprise to you, and maybe it'll tell by my facial expressions whether or not I'm impressed or not so impressed. So that being said, let's go ahead and do the first. We're gonna do samples of 30. So if you're not familiar with this particular test in the console, it's basically probe _ accuracy, and that will run 10 samples. That's the standard. But if you do a space and the right samples equals, you can run as many times as you like. You can run it for 30, you can run it for 50, you can run it for 500, you can run it for 1,000 if you like. They do tell you to break it in by doing 100 or so. I've actually broken it in every time I've done this test before I've done a video with about 500 samples, just to get it going where it's going. I'll say one more thing before we get too far into this and you say, well, what about this? What about that? This testing is taking place in the same relative spot that the other test took place on. Without the build surface on there, we're doing it directly on the plate. And the reason for that is because it's the same. It's the same every time. It's about as flat or as base to the surface as I can get is the actual surface. 2 is, since we now have the kinematics mount back on there, is I will also, as part of this testing, do the front right corner, which is a point of contention. It's the issue area, if you will. And when I do that, I will do it in 2 places in the front right corner. I will do it as far forward and front and right as I can, and I'll also do it in a reasonable place where our quad gantry leveling kind of takes place, which is not necessarily on the very edge of the corner. So without any further ado, let's go ahead and start this with the center. First sample here, and again, that little camera up there does have a little bit of a delay. It's about a half a second or so, so hopefully it doesn't drive you nutty, because I'm sure you can probably hear that in the background, and it may not match up completely with that. It's gonna be kind of like watching me if my lips didn't match my mouth, but hopefully they do, right? All right, so first one is done, and not a great reading, I will say. Let's see here. I'm gonna grab that. And paste that in, values only, and we'll take our min and our max as well. And I will tell you, I will tell you that, is that our max? Yep. That as of current, our first run is I gotta look real quick here. Put in the wrong spot for one, but is the almost the worst. It's not quite the worst. It's actually better. So this we gotta stay to the end of the video. It's better than it was on the standard tap heated bed, but we're not heated, so yeah. So let's jump into the second one while we're talking about that. So hopefully with the heated bed with this tap, if my thought there with the plastic being warmed up just by the air around it is anywhere near true, we should see more consistency with the CNC tap. And I've said it 1,000 times at least that consistency a lot of times is worth more than precision when it comes to 3D printing, because you can plan on things. You're never going to have 1,000% precise anything. You know, hey, it's 1,000%. It's more than 100. But you aim for that 95, 98%. You're excited if you get anywhere in that ballpark, but you're okay if you get to that 93%, 90%, and then you basically make modifications. I mean, that's why people make modifications to their print codes, why people make modifications to their slicers, but consistency is key. So let's see here. On the second run, and we're holding this kind of a little bit of a secret, I saw a much better number. You don't get to see them yet. It was actually doubly good of what we first came up with for a number. And let's grab that. And let's paste that. And let's grab the next one. And let's paste that one. All right, and run it again. So this is test 3 of the 5 tests that we're going to do again with the Kinematics bed. Cold, nozzle cold. Looking pretty good. Print is looking pretty good too. If you're not a member of the channel quite yet, if you go over there and take a look, if you become a member, that's awesome. If you don't, at least go in there, look in the not the comment section, but the community section, and I've been posting some pictures and stuff like that. Some pretty neat stuff. Let's see here. This next number we got, and we've gotten even better again, which is interesting. So we're on the third test of the same exact test, and our standard deviation got better, which isn't abnormal. Just getting into the groove of things, right? So, whoops, and paste. Yeah, okay, so interesting. Yeah, all right. And test number 4. I had to put the little thing here just so I don't get so boring to listen to. I figure it's kind of neat to be able to see that really close up. And what you're seeing there, because it looks kind of strange, is you're actually seeing that nozzle tapping against the bed, and it's directly behind one of the mag bed magnets, which has a screw in the middle of it to hold it all together and down. That's that weird looking thing that you're seeing from extreme close-up, if you didn't know. Bed is awesome. I will say if it actually matches, I have no way to measure to be 100% certain that it matches what the measurements were that came with the bed. But I will say that if it does, it is very, very good. I think it was 0.002, 0.00 or 0.00. Yeah, it was very, very flat. How about that? It was probably flatter than anything else I have around. So yeah, and so we've deviated slightly. We're not quite as good as the last time, but we're pretty decent. And this is the 5th sample and the last sample in this run before I actually kind of show you what we got. This will be interesting here. The reason I'm doing 5 samples is obviously, just like anything else, sometimes you get some oddballs in there. I figure 5 is kind of a safe number. Again, this is not a scientific measurement or test here. This is simply me showing kind of what I'm coming off with in terms of what I got, and seeing whether or not I feel this product is good and whether or not it works properly with the Kinematics bed in my setup. Your setup might be slightly different, but this might give you a little bit of insight, at least if you're on the fence on what to do. because as we all know, it's the internet and everybody has their own opinions about everything, times 4. So let's see here, paste special values only. Cool. Okay. So now that we have all 5 of those done, and we're at a point where I can show this. Let's switch views. So this is what we just did for information here, and our average across the whole board on standard deviation was a 0.001156, which compared from the top here, standard tap, we were with a cold bed, cold nozzle, we are 0.0008142. So we were actually better with a standard tap than we are currently with the CNC tap. But again, that's a standard tap, cold bed, cold nozzle with a screw down bed. So basically the bed nailed down tight. I didn't even leave the screws loosened like you're supposed to. So you're basically usually supposed to have one screw that's relatively tight, one screw that's semi-tight, one screw that's even looser, and then one screw that's barely holding on by 2 threads. So that was a tight bed. Not great for heating it up, stuff like that. So I didn't want to run a long time with that. But then standard tap, we did it with a heated bed, heated nozzle. We had a 0.005. So we are better than that. We are at 0.0011. So we're better than a standard tap with a heated bed by probably a pretty decent amount. Our max is 0.6, where there it was 0.11, and our min, actually those are gonna be hard because now the bed's at a different height, so those kind of get thrown out. It's a deviation we got to look at on this at this point. So anyways, yeah, so 0.001 is way better than 0.005. Now on the CNC tap with a cold bed, we're at 0.0005, so obviously we're nowhere near that. And with a heated bed, we're at 0.0015, which is slightly worse than we're at right now with our 0.0011. So all in all, currently we're somewhere in the middle of better than either one was heated, not quite as good as either one of them was cold. So let me heat up the bed and we'll talk about a couple other things here while I'm doing that. Get the bed up to 70. It's going to take a minute. I apologize for that, but I can only do what I can do, right? So we'll get that done. Yeah. Good. All right, and we will come back over to this guy right here, I think, and talk a little bit about this printer thus far. So as of right now, this does have a top on it. I put it on there just to keep it safe. We have our lighting inside the printer all set up, our LED lighting, which is pretty neat. We have our stealth burner lighting all done inside this thing. We have our custom backplate here. Let me show that off actually in camera 1. You can kind of see it a little bit here in the back. The camera's a little low. It's more focused on the actual stealth burner, but that's okay. So anyways, we got that all done. We have our Kinematics bed back in here, which we gotta make sure we don't touch. We don't want to mess with this. We have nothing on the side yet. I'm working on something like that. That's basically, I'll just tell you. Basically, my side walls here have the BIB or the Build It Basement logo on them, and I'm looking for a decent way to side light them. So those aren't on there yet. I have my clipper screen all ready to go. It's all set up on there. But basically, I could do the software video for that, so I can kind of go over that. I did a previous video, one of my live streams. I've been doing gotchas during those live screens, and one of the gotchas I had specifically to do with the clipper screen, using the specific screen I had using a Pi 4. So I want to definitely have a video come out on that. It's probably going to be the next video I do before we jump forward and we actually go into tuning this weekend during the live stream. So let's see here, we're at about 43 degrees Celsius. The nozzle already is up to temperature, of course, and I'm running out of things to say. So, moment of silence. About the Kinematics bed, just so we'll talk about that while we're waiting for this little final bit here. It's been off the printer for a little while, so you may not have seen it depending on if you're jumping around through the videos or not. And if you are jumping around, I do ask, it'd be awesome if you go back and look at some of those other videos, because I do cover all this stuff. But this bed is very special. It is honed down very flat, machined 100%. The company's called Mandela Rose Works. I believe they're out of the, where are they out of? Maybe the Midwest here in the United States. I forget what state specifically, but they are west of me, and I'm in Maine, so that pretty much covers everybody. So special things about this, it's machined really flat. On top of that, it's the Ultra Mag, so they have these very, very, very strong neodymium magnets in here that are donut shaped. They are basically just slightly under the surface of the print bed, so when you put your surface on there, they do not raise up proud of the bed whatsoever. They are flat to the eye and nearly flat to the touch. They're very special because they're actually ring shaped, so they have a bevel emboss them, so they can have these little Phillips screws in them that hold them down, so they can come off if you had to. I don't know why you'd want to, but yeah, so beds on this hold on really well. Again, I don't want to mess with the bed right now, but I do want to say that the bed, the build surfaces that you put on this hold really well. You can actually put a build surfaces on the front magnets and it will hold itself out there kind of like a springboard. So it's pretty neat stuff. I had a few conversations, and I'll talk about this for a second, and it has to do with the outriggers they sell for these beds. Mandela Rose makes outriggers, and basically what it does is it widens out the back supports for the kinematics mounting system. The front's always going to be a center point of one, but basically based on how the Voron printer is built to the Voron spec, the bars that you're mounting to for the kinematic system are a little close together to make you a true triangle. It is basically a little bit smaller on the back side to keep things simple, and because of that, you don't have exactly the same amount of balance that you'd have as if you had that full size. There's not as much surface area as a full-size triangle. So they make these outriggers that basically push out the sides, the mounting points on the sides to other locations that are pre-drilled on the bed so that you can have a better, wider surface. I had a specific conversation with the owner of Mandela Rose Works about that, and basically what it came down to is on the 350, his feeling was you do not need them whatsoever. This is a 300. On a 300, you probably don't need them. You may want them, you may not want them, but chances are you don't need them. They're not a waste because they look beautiful, but they're not really needed. On a 250, you do need them. So if you're building a 250, you need them. If you have a 300, it's a crapshoot. If you have a 350, if you want them for the looks, great. Other than that, you don't need it. It all has to do with basically the size of the bed and how much area you actually have in that triangle that you're mounted to. Take a look here. We're up to 70 degrees now on the bed. It is toasty, so let's jump back into our special little nozzle cam there. You can tell it looks a little warm, right? Not so much. Let's go ahead, and now that we have a warmed up nozzle in bed, let's see what we got. Why, oh why? Oh, I see what's going on here. We'll have to fix that. All right. Got a little math issue with this last testing thing, so I'm gonna have to fix my averages. It's pulling in too many numbers, but we're gonna go and run the bed sample on this for 30 samples. This is with the 150 degree nozzle and the 70 degree bed. And while we're doing that, I'm gonna do my equals average and what did we get? We got a number. Again, I'm not going to tell you. This time I'll just go to the third number before I tell you what we got, and then we'll play that game a little bit. I don't need to keep you in complete darkness here, because I think you probably have some idea where we're going to wind up. If things prove to be where I think they should be, not to spill the beans much, but I think we should wind up with very similar numbers with the heated bed, with the kinematics mounting, because the bed shouldn't be warping at all, and the CNC tap shouldn't be basically changing at all. It shouldn't be manipulated by the heat. Might expand and contract some, but it should be nothing like what can happen to that really thin plastic that you have on the Voron. Oops, I went ahead and put those in the wrong places here. Let me grab that. Copy, paste, copy, paste. We'll do that, do that, do that. And then we're going to run our 30 samples again. You guys can watch that for a second while I fix this. And she's finished up. And what do we get here? What's surprising? Well, that's not too surprising, but not too shabby, I'll tell you that. This is a good test as to how much you're into 3D printers, because if you find this suspenseful, you love your 3D printers. If you find this boring, you probably should find a different hobby. And yeah, so let's go ahead and hit that one more time. This is the third one. I told you I'm going to unveil where we're at with this third one, because I think it should be very similar to the last one we had. And you guys will see whether or not that's true or not, and see if my hypotheses on this subject are correct. So there we go with that. We actually got a very good number with that one. And by very good, I mean pretty good. There are some expectations that are out there in terms of what we should be seeing for these. I am the type of person that thinks consistency is much more important than a lot of other things that people talk about. So, yeah. All right, so let me drive this down to this. We'll say bye-bye right now to that nozzle cam, and we'll talk about where we're at right now. So right now, with the third test, we're at a standard deviation of 0.001026, which is very, very slightly better somehow than we were with the cold bed, cold nozzle, but pretty damn close. It's almost no difference whatsoever on that. So we're going to run our samples here. We'll let that glide away on the side as we go. And if history is repeating itself here, we should be around 0.00078-ish. And we wound up with a 6. So we wound up a little bit better this time. Not bad. And we'll grab, in actuality, I probably don't even need to grab these anymore because, well, I guess we'll compare them to the other one with the kinematics bed on it. But it doesn't matter compared to the when the bed was mounted differently. So if you got questions about this too, please do leave a comment, ask questions. I think I answer every single comment I get. If it is looking for an answer, I at least recognize that something's been sent there if it's just a normal comment. But more than willing to answer questions. I try to do live streams once a week on the weekends, usually around midday on Saturday or Sunday, usually Saturday, but sometimes Sunday. This week it's Sunday because of some stuff I have going on. And this time around on this one, we again got a 0.0007. Whoop. And there, and we'll go and grab our maximum again. And you guys are probably looking at this. I'm not even looking at the numbers quite yet because I gotta paste them in, but I'm just as interested as you are if you've gone this far along. And what are we at? So overall, we are at 0.0008986 with similar max and slightly less min than what we had with a cold bed and nozzle. Now, here's the clincher. 0.0, so 3 zeros, 8986 is better than it was cold. I can't explain that. So again, this is not wholly scientific here. If you have an idea as to why, then by all means, leave me a comment. But with the CNC tap originally with the bed that was nailed down, which is not something you normally want to do with a bed, we saw 0.0015, which is not great. It's much worse actually than we are with this heated bed. And with the standard tap with a 7-degree bed, 150-degree nozzle, we had 0.005, which is not great either. So this is the root. This is what I wanted to talk about. This is why I did this, is when you're using a kinematic system, you basically have a floating bed. You have a bed that's able to do what it needs to do to expand in the proper directions that it can expand into, as opposed to doing things, you know, in the bed oddly. And this is heat soaking while we talk. It's not heat soaked, and there's a purpose behind that, is because as it heat soaks, things are going to move, you know, microscopically, admittedly. But what I wanted to show, what I thought was going to happen, what proved relatively true based on my testing, and do test yourself if you'd like, is that with a heated bed, with the CNC TAP Kinematics mounting system, your precision is much higher than it, or mine was much higher than it would have been, or that was, with the original TAP with a flat bed on that printer. So that answers that question. And then the last thing I wanted to do is I wanted to show you guys, and let me actually do this. We're going to bring the tap forward, and let's go back down to this PDF screen like this, with me up here and that in the picture, this guy right here. And I want to run the same code. So this is about roundabout where my quad gantry leveling happens here. It's not to the extreme front right of the printer, but it is relatively front right of the printer. So this would be your normal test, or your normal, what you'd see on a day-to-day basis if you were doing your quad gantry leveling on your printer. So let's run our sample test on that. We're going to do 30. I will tell you, by looking at the bed visually, I don't want to touch it because I don't want to skew anything, but I'm not seeing any movement in the bed with the head where it currently is. Again, this is about on a 300 by 300 printer where it would be if you're doing a quad gantry leveling. And our number that we just got here for standard deviation, and I'll just paste it right here, is a 0.00834, which is admittedly right in line with everything else we got. It is almost damn on the average of what we'd had before. So let's go ahead and let's move that a little bit further. So let's pull this. There's only so far I can go because I don't want the nozzle actually on the screw head. But that right there, actually I'm gonna switch over to the nozzle cam real quick here, so let me do that so we can see what we got. So let me just do a quick Z. That's not what I wanted. All right, let's move that back where we want it. And I think we'll be okay right there. Let me bring that down now. Okay, so we're not on that screw. We can see it right there. Clear as day, heated bed. We're in the front right corner. Let's go back to the screen share so you can see where we're at. I mean, my stealth, this is live. The stealth burner is all the way front right, 300 by 300 kinematics bed, CNC tap. And now what I'm going to do is run our sample test. And I think this one isn't going to be great, but again, we're pushing this to extremes. This is where you normally run a sample, okay? Oh, probe triggered. Oh, let me. Gotta take the nozzle off the bed first. All right, let's do that. I'm not seeing the bed moving, but I can tell you the sound is slightly different. It sounds a little duller. What do we got? Not bad. Interesting. Okay, not what I was expecting. So we have a standard deviation on this of, I'm pretty damn impressed actually. We have a standard deviation on this that actually, you know, again, hair of a hair splitting, is right on with what we had for our full test with the average, as well as what we had in about the location where we do a quad gantry leveling on this whole front. Now, I just got to push this all the way as far as possible. I gotta, let me bring it so we can see it again together where we're at, because I just don't want to get on that screw head. And I don't know. So that would put us on the magnet. I can't go further. Can I get on the other side of this magnet? That is as far as I can go, but what can I do over here? Right there. Right there. Perfect. Okay. So it's actually laughable as to where I am with my stealth printer right now. We all know that the beds are slightly larger than the actual print surface or the print volume on these things. So I could, if I wanted to, let's see. Oh. I could get over just a little bit more. I'm at 295. So I'm exactly 1 millimeter away from the edge on the front side on the Y, and I am exactly at 299 on the X. So I am, for all intents and purposes, as far over and forward as I'm going to get with this setup. So let's go back over to the PDF, or not PDF, the screen share. It's called PDF on my Stream Deck. And let's run that code one more time. Let's do a probe accuracy, and this has got to mess up. I mean, I will be so impressed. I will send an email tonight to the gentleman that runs Mandela Roseworks and tell him how impressed I am if this is just as good. And I'm not seeing the bed move. I'm not gonna say anything about the sound because last time it sounded a little different to me, but at this point I think it was probably my ears playing tricks on me. And what do I got? Okay. Phew, I don't have to write any long-winded emails about how much or how good things are, because that'd be a pain. Here's what we got. We got 0.001297 at the tap interfacing at the most forward right section, which is the weakest portion of this bed. And that is still, in my book, within reason in terms of, you know, splitting hairs again. It is by no means quite as good as it was just a little bit further back. Let's run it one more time just to make sure, because I don't want anybody to say we should ran it multiple times. And again, not a scientific test, just a testing for myself that I'm sharing with everybody. And we'll see what we got here. We have, okay, standard deviation 0.001152, so pretty much exactly where the other one was. Perfect. All right, so that's the final video that I'm going to do specifically with the CNC tap and the Kinematics bed. Kinematics bed is fine, the CNC tap is awesome. Actually, Kinematics bed and mount and this whole system setup here I'm very happy with. If you're building a Voron 2.4 R2 or rebuilding one, which I'll be doing very soon, by the way, this is a good setup. I think it's a good setup. It looks like it's a good setup. It's working very well. I don't see any issues with it. Even the issues I thought I might have don't seem to be issues. So one more time before we leave, if you haven't subscribed, please do so. Give me a thumbs up if you enjoy this type of content. do try to join me this weekend. If you subscribe and hit that bell notification thing, you should get notified. I can't guarantee you will, so do stop by the channel and see what's going on. If you'd like to help out a little bit, go ahead and become a member of the channel. I appreciate all that. It helps me buy things so I can show you how they work, and your little toss of a coin inside that jar really gets multiplied by the other users as well, and together we can kind of do this type of stuff, and I can put out content for you guys. I can have fun, you guys hopefully get entertained, and that being said, I'll see you next time.